Okay, let's see. So let's get a brief understanding of the innervation of the cardiac muscle. So we have, let's just say, our nervous system control of cardiac tissue. Okay, so in our heart, we can look at it from a couple ways. Let's use this diagram this way. Let's use the heart as a big box, big square this way. Let's divide it into two, with the top being the atria, the ventricles. Help if I can spell today. Let's just start that over. Ventricles. Okay, so we have atria up top, ventricles on the bottom, just like in our heart. And we know that we have two divisions of our nervous system. We have a parasympathetic nervous system and a sympathetic nervous system. Parasympathetic nervous system keeps things slower, toned down, the breed and feed. Sympathetic, we know that as our fight or flight. And each one of those do different things. They have different neurotransmitters acting on different types of receptors on the cell wall. So this is autonomic innervation of the heart. And let's start over here with the parasympathetic. The parasympathetic is in charge of keeping our heart rate at our resting rate of around 60 beats per minute. So what it does is it keeps us toned down. It keeps what is collectively known in physiology as the parasympathetic brake on the heart. It keeps it going a little bit slower. It's equivalent to the analogy of you driving your car with your right foot on the gas pedal and your left foot on the brake, just to keep the car going 35 miles an hour, even though you're giving it more gas. So that's how the heart works. There's a intrinsic beat. The SI node, the sinoatrial node, has its own intrinsic beat or pacemaker potential that keeps the heart beating around 100 beats a minute. The parasympathetic then tones it down to around 60, keeps the brake on it. And it accomplishes this via the vagus nerve. And we're just going to do one of these, a little synapse here. The vagus nerve. And we have over here a muscarinic type acetylcholine receptor. So in this case, the vesicles being released at the end of the axon terminal is acetylcholine, ACH. So this is acetylcholine receptor at this point. So they diffuse over here, and this keeps the atria toned down, the intrinsic beat of around 60 beats a minute. However, we need to have some type of mechanism to help us get away if we're being chased by a lion or hippo or other crazy thing. And we have our other side of our autonomic nervous system, the sympathetic. And this is going to first bind up here. We have a beta andretic receptor type right here. And right here. And this is the thoracic spinal nerves. And it's going to release norepinephrine. But we also have to consider that in our sympathetic nervous system that we have epinephrine being released into our bloodstream. So our blood vessels is going to release some epi. And that's going to bind up on another beta andretic type receptor here on the ventricles. And as you might imagine, sympathetic nervous system innervation, the fight or flight, is going to cause an increase in heart rate. The reason it causes an increase in heart rate is because the parasympathetic is being overruled at this point. Norepinephrine, epinephrine, norepinephrine from the sympathetic thoracic spinal nerves is causing stimulation of the atria, increasing the contractions, as well as epinephrine from the bloodstream binding up at the beta-androtic receptor on the ventricle, causing increases as well. So when you're being chased or you're in a situation where you're under distress, the sympathetic nervous system is going to overrule, going to get your heart to beat faster so that more blood and nutrients and oxygen can get to the working tissues. So once again, beta equals beta androtic. We just start that over. Beta adrenergic. It's too early. Having trouble spelling. So that's our basic innervation. Parasympathetic keeps the beats at resting, being chased by a bear or other some type of distress. Norepinephrine is released via the thoracic spinal nerves, binds with the beta-androtic of the atria, causes it to increase its contraction, increase its heart rate, I should say, as well as the ventricles, epinephrine in the bloodstream binding up with the beta-androtic of the ventricle, helping that as well.